We've looked at a lot of components, spent a lot of time looking at different components. Let's put into systems and see what they look like. And specifically, I want to look at a couple of different types of systems and how we put multiple directional control valves together, control multiple loads simultaneously or sequentially or so forth. So that's what we're going to look at, how we do that. And so we're going to look at a couple different types of systems. The three main types that we're going to look at is the open-centered, closed-centered, and then a load sensing system, which is what a lot of our modern mobile equipment and even stationary equipment use, a load sensing system. And we'll look at how we handle multiple loads, how the different systems work with multiple loads. But I want us to be thinking as we go through this discussion, what about the neutral conditions? So we can think about how it works when fluid's flowing and we're doing energy and you know, stuff's happening, but a lot of times with mobile equipment, we're not actually doing work. So we don't have all the actuators going all the time. In fact, sometimes we don't have any actuators going. So how much energy am I using when I'm not doing any useful work? And can I design the system so that if I don't need any downstream work, I'm not creating any energy and making extra heat? And so that's where we're going to look at the neutral conditions, what happens for neutral conditions. So let's tear into these. So the first one is an open-centered system, and this is a relatively old system. A lot of older mobile equipment, older tractors would utilize an open-centered system. These are not as common now, but an open-centered system, you can see how we talked about that open-center valve. Technically, it's actually a tandem center valve, but we can see that the centers are connected together in series, so the oil can freely go through the center. So like this, it freely goes through the second center. This is the neutral conditions going back to the reservoir. So we want to think about at neutral conditions, what is the status, how much flow, how much pressure is going through the system. So neutral conditions right now. So what is my flow? High flow or low flow, and I want to look at the pressure, high pressure, low pressure. So in an open center system, in neutral condition, the flow goes through both valves, dumps right back to the reservoir. Apparently very little resistance. Now we know that it's somewhere in here we're probably going to have some filters, and that was a really bad drawing of a filter that was supposed to be a filter, so that's terrible. Let me clean that up. So we're supposed to have a filter in there. So yeah, there's going to be some pressure drop across that filter. There's going to be some pressure drops with the fluid flowing through these valves because there's going to be turning corners and going through ports and stuff like that. So there's going to be some pressure drop, but it's going to be relatively low. So relatively low pressure, relatively high flow, okay? And pressure, or the power, fluid power, remember, is Q delta P. So in this particular case, if my delta P is 0 or near 0, my power dissipation is relatively close to 0, and so I don't get a whole lot of power usage. So not a lot of power wasted. So that's the neutral conditions. Low pressure, high flow, okay? So now there's some interesting things that happen here. Let's think about actuating this valve. So if I actuate one of these valves to extend this cylinder, so fluid flow, the valve would slide to the right, fluid would go up through this arrow through here and extend the cylinder, it would come back through this arrow, come back to this line, it would have to go through this cylinder, through this valve, and back to the reservoir. So that's the path of the oil, and that would work fine. But what's interesting to think about is what happens if I activate both of these valves at the same time. So let's say that everything is relatively identical in size, so identical size valves, identical size cylinders, even identical loads on there, although in this case load isn't going to matter. So let's think about what's going to happen. So I activate both valves at the same time and I want to lift both of these cylinders. So follow the path of the flow. So the flow comes up through here, it goes through the left arrow straight out into the extension side of the cylinder. The cylinder extends, the flow from the back side of the cylinder comes down through here, comes over here. Now from this valve, it's going to go up through the vertical arrow, and it's going to go up into the extension side of that cylinder, all right? And the flow then comes out of that, comes back through this arrow, and then goes down through the filter, back to the reservoir. All right, so what does that mean? Does that mean both cylinders lift? So do they have a choice? So let's think about this. What I've essentially done is connected these two cylinders in series. What that means is that the flow from the intake or the extension side of this cylinder goes into here. The retraction side of this cylinder comes out and goes into the extension of this cylinder. All right, let me redraw that. Maybe it'll help us to visualize it a little bit. So I'll go back to my pen. So I've got this cylinder. I'll draw them vertically here, put them in a different direction so we have a different view on it. So I have fluid coming into there, fluid is coming out of that one and going into this cylinder here. So this is the situation that we've created. And then the flow out of that cylinder goes back to the reservoir. So now let's think about this. Those are both identical cylinders. Will they both raise? Will they both extend? Well, certainly, because the fluid coming in is coming into here, so the fluid going out has no choice but to go into the extension side of this cylinder. So yes, this cylinder is going to extend. The question is, will it extend all the way? That's where we got to look at the volume of oil, how much oil has been displaced out of the backside of the first cylinder. Remember, we got this rod in there that's taking up space. So the volume on the extension side of the cylinder is larger than the volume on the retraction side of the cylinder when the piston is at one side or the other. So what that means is if I start with this cylinder all the way down, there's a smaller volume in the retraction side of that cylinder than it would take to extend this cylinder all the way. So what happened is this cylinder would come out to extend all the way. We'd have a smaller volume of oil. This cylinder would not extend all the way. It would only extend a partial distance. And then the flow from there would go back. So the only way I could get the second cylinder to extend, if I go back to my circuit, is to drop the first cylinder back to the neutral condition, so now I can have a little extra flow go in there, hold the second valve open to get it to extend both ways. So I've essentially connected those two cylinders in series. The nice thing is they both move. The bad thing is that they won't extend all the way. Now, I do know of situations where they use something like this. And actually a story from my uncle who passed away a couple years ago. He was a mechanic in the Air Force, worked on airplanes. And he said they would connect cylinders like that in airplanes all the time. They would connect them in series. So one after the other, one after the other. And what they would do then is the second cylinder would be smaller in diameter than the first cylinder. And they would be designed such that the flow, the volume of oil in the retraction side of the first cylinder would be enough to extend the second cylinder. And they do that so they don't have to run as many hoses or many lines throughout the airplane. That reduces the weight, reduces the amount of fluid that they need in the airplane, gives them a little more payload. It's a better design on the airplane. So we can do that, but we just need to be aware that the second cylinder needs to be smaller than the first one. The other thing we need to be aware of in a situation like this is that the pressure effect. So what is the load lifting capacity that I would have on these two cylinders? Because I have flow coming in one point here, so the pressure that I develop here, that is developed here, has got to be enough to overcome this load as well as this load. Look at load B down here is pushing back, so that load is actually creating a back pressure on cylinder A. So that is going to be a very high back pressure on cylinder A, enough to be able to overcome the load on cylinder B. Then in addition, whatever filters and stuff that I have going back to the reservoir, there's also going to be a back pressure on side B. So this load up front here, the pressure up front, has got to overcome all of those pieces because they're all in series down through the system. So it drastically reduces the load lifting capacity if I want to do them at multiple times. If I just do one at a time, then I can still lift the full load, but I may not be able to lift both of them at the same time. So that's an open-centered system. So we end up with our cylinders connected in series. Could be a problem, may not be a problem. I actually grew up with a tractor that had a system like this, and we knew this kind of behavior. You expected it, you just learned how to operate around it, and you dealt with it. This is a very inexpensive system because this is generally a gear pump, a very simple gear pump. We would also have to put a relief valve in this system to protect it. So this would also have to have a relief valve in there to make that happen so that we wouldn't break the system. So relatively inexpensive system, and that's why they build them that way. Now, the next generation, if you will, went to a closed-centered system. And so you can see this is a closed-centered system. Valves are different. Now we have closed-centered valves. So you can see that the flow cannot go through there when in neutral conditions. So what about our neutral conditions? What is our flow and our pressure at neutral conditions? Well, neutral conditions, we don't have any flow. The flow can't go up here, it can't go over here, it can't go anywhere. So guess what? We have zero flow. But what's going to happen to our pressure? Our pressure is probably going to be really high. So this is where we're using one of those pressure compensated pumps. So the pump down here is pressure compensated. It's one of them where usually a radial piston pump. Could be an axial piston where we have an actuator on the swash plate that will bring it back to zero. But we pressure compensate this pump and say, hey, when there's no flow demand, when the pressure gets really high, it's like, hey, quit pumping. Don't be sending any more down there. So we sit there at a really high pressure, but we have a low flow. And so again, pressure times flow is zero power. So that should be a relatively low power usage when I don't have a demand downstream. Okay, now how are my cylinders connected? Same exercise. I activate both of these cylinders. Let's follow the flow path. The flow comes out of the pump, and now it's got a junction here, so it has a choice. It could go up to cylinder A, or it could go over here to cylinder B. Okay, so, and if both of these are set in the extension position, the flow can either say, hey, I'm going up into extend cylinder A, or I'm going to go up into here and extend cylinder B. So where am I going to go? Well, it depends on what the load is on each one of these. So what is the force on A and the force on B? Because here's where we'll get what we call sequencing. So again, key is that it's the downstream load that causes the pressure. Okay, so when the downstream load, when everything is shut off, I have a really high downstream load and it causes the pressure to go really high. When I open both of these, the pressure is going to drop immediately. The pump is trying to push flow out there. Now these cylinders up here are going to are the ones that are going to be creating the pressure buildup. At some point, the pressure is going to get high enough that these cylinders are going to move. Now, if these loads are not identical, then the lighter load is going to move first because that cylinder is going to cause the pressure to build up enough to move it, but that pressure won't be high enough to move the other cylinder. So what will happen is one cylinder will move. When it hits the end, it can't go anymore. Now the pressure will build up enough to be able to extend the second cylinder. So we get this sequencing effect. And that may be a big deal or maybe not. I talked before about how if we have two wings on a machine that we want to fold up, and maybe I don't want one wing to fold up before the other, it's important that they both fold up at the same time. Then I'm going to have to do something different. So that's what a closed-centered system will do for me. It's going to give me that sequencing type operation there. Now, the best of both worlds, if you will, is what we call the tandem center system or a load sensing system. And it's a whole lot more complicated. You can see more lines and stuff going on there, a lot of stuff happening. But what we've essentially added now is this dotted line. This is a load sensing line or a pressure sensing line that comes back. So instead of, we still have the pressure compensated pump, and we still have this pressure compensated, this valve here like we saw in the closed center system. So the main flow, if you look at the main flow out of the pump, it comes up through here, and there's that can't go there, so this is closed off. It can't go here, that's closed off. So it acts like a closed centered system. So I have this pressure compensated pump that de-strokes itself. So it doesn't pump anymore. But now what I'm going to do is sense the load on each one of these down here. And I'm going to, when I activate both these valves, they're both going to want to move, or the flow can go to both of them. The pressure sensing line is going to say, hey, I've got, what is my demand downstream? And what's going to happen? And I'll let you follow through the logic on this. It takes a while to wrap your head around it, but essentially this pump is going to stroke itself enough, so get enough flow coming out of it, that it's going to lift both of those loads. And one of the keys to make this work is I got to have a little bit of throttling on both of those lines. So I have to have a little bit of restriction that says, okay, I'm not going to let all of the flow go down both those lines. I'm going to back it off a little bit. And these can be pressure compensated valves, so they don't have a lot of pressure drop in them, but I'm going to hold them back a little bit so that the pump has more capacity than I need for either one of these valves. Well, that load sensing line is going to sense the highest pressure demand. The pump is going to send enough flow down the circuit to take care of the high pressure demand, which in the same time, because of these throttling valves here, is going to also take care of the low load sensing, the low load line as well. So even if I have two cylinders out here with different loads on them, they're both going to move. So I eliminate the sequencing effect of that I saw in the closed-centered system. So neutral conditions on this one. If we go back to the neutral conditions, this one is nice in that we have a low flow, just like we did in the closed-centered system, so there's no flow going out there, but because we have the load sensing line back there, we can also reduce the pressure. And so the neutral condition, the pressure is also low, so it's a low flow and a low pressure, so there's no, really reduces the amount of power we use in neutral conditions. This is what is used in most modern mobile equipment and modern fluid power systems. So we have this extra load sensing line, so we have to think about that load sensing line, what it's sensing, and make sure that the priority is given to each one of those systems so that they all move at the same time. So again, it steps it up a little bit in complexity in terms of the design and so forth, but the functionality is really nice. So that's kind of an overview of all of the systems, the different types of systems. I want to take one more module here to look at some electrohydraulics, again looking at where we're going with some of this hydraulic stuff, the fluid power stuff, the modern controls and so forth. But that wraps it up for the systems.